Hi everyone, this lecture deals with the implementation of image blurring technique, or you can say image smoothing technique, where we go for applying averaging and we do the practical in OpenCV using Python. So you are with me, Dr. Divyajyoti Bora. So let's start the class. Image blurring is achieved by convolving the image with a low pass filter kernel. You know, in the last lecture, we have discussed a lot about kernel, low pass filter, high pass filter, what is kernel, what are the specific kernels. So we discuss about those things. You please go through that last lecture, then your concept will be clear, right? So we got to know that image blurring can be achieved by convolving the image with a low pass filter kernel. Now, it is useful for removing noise. It actually removes high frequency content, as for example, noise, edges from the image. Because we know whenever noises exist, obviously that value is different from the neighboring values. And that is a high frequency content. Either it is a noise or edges. They are generally high frequency content. So it will remove those high frequency contents. So edges are blurred a little bit in this operation. There are also blurring techniques which do not blur the edges. Now, OpenCV provides four main types of blurring techniques, and today we are going to do the averaging method, right? Now, this averaging, the others we will discuss in the remaining classes, in the coming classes. Now, today we are focusing on the averaging. So this is one of such blurring technique, and this is done by convolving an image with a normalized box filter. It simply takes the average of all the pixels under the kernel area and replaces the central element. Got it now? It takes the average of all the pixels under the kernel area and then replaces the central element. And this is done by the function cv.blur or cv.box filter. Then check the docs for more. If you want to know about this, more about this, you just type this and you get to know a lot about this function. But basically, this information is sufficient. Now, we should specify the width and height of the kernel. A 3x3 normalized box filter would be look like this: 1/9, 111, 111, 111. Well, in the last lecture also, we discussed a lot about this kernel and different kernels. So you now easily understand that in this case, we are going to use this particular kernel, and that is 1/9, 111, 111, 111. Now, what will be the code? Code, you can take a screenshot of this. You take this and try to implement this by your own. Import CV2 as CV from matplotlib, import pyplot as plot, then give the location of the input image. Here I am giving this location of this Lina image. Okay, then that is being read and main place in this variable img. If not found, this message will be printed. File could not be read. Check with os.path.exist. Now, this is the first part, blur. This is done with the help of blur function. Okay, now image cv.blur, the parameters are, the first one is the input image and the next one is that is the size, right? Height and width size. Here we are using 5x5. Now subplot 1 to 1, the original image, plot image show, plot title original, x ticks and 1 ticks, then plot subplot 1 to 2 because we are dividing the plot into two subplots, then plot image show blur, that is the blur version of this image, plot title blurred, x ticks, y ticks, plot show. Got it? Each and every line of the code discussed. Now let's try to implement this code in our OpenCV using Python. For that, I'm opening Spider from Anaconda. So we have written down this code. Now let's try to implement this. Now see, we got the output. This is the original image and this is the blurred version of this. As I told you, blurred version edges may be removed or noises will be removed because they are high frequency content. You can clearly see this edge, you can see. Let me show you quickly. This one, right? But here, just a minute. Let me choose the color. Okay, this one. Now here, if you see properly, then this edges being blurred or smoothened, right? Because the edges having how we define an edge, where frequently changes mean sharply, the values become very high, right? It comes to the peak. So high frequency concert, that's why it is being blurred, right? Similarly, here also this in this case, this edges well, then other, if you clearly notice the images, two images, because you have to analyze this, right? You are as a image processing expert, you should have the ability to analyze it. So you can clearly distinguish these two images, how the edges being blurred. Otherwise, noises are removed to a bit to a satisfactory level. So our means task been done, image being filtered, and we are using averaging, means we take that particular area, that is 555, we take the average value and replace that central value with that particular average value. In that way, we got the blurred version of the image. Clear? So that's it for today. This is sufficient. Please don't skip the practical, do it by your own, and let me know if any problem you are facing in the implementation stage. Well, so with this, I'm signing out. Take care. Bye bye.